So let's get started. I want to start off by talking. Yeah. Did you turn it into me? Yeah. Okay. Well, then I gotta find it because it wasn't in that file.
Oh, you're getting.
What's that? I am.
You can't get away from it.
Yeah. So, anyways, I want to talk about this lab. So, take this in mind when you finish your lab from last week that is going to be due tomorrow. Okay. So, some of the issues, like with coming up with errors, a lot of you guys said things like the scale was wrong or I calculated wrong. Well, for one, the scales aren't wrong, so that's not an error that you can use. Also, like if you calculated wrong, just don't do that. That's a human error, so it's not a valid answer for that. So another thing that came up a lot is some of you wrote the word spit or saliva or something along those lines. I want an explanation of why that affects your answer, not just like, oh, spit was in the gum, but why does it matter? Somebody tell me why it matters. Yes?
Adds weight to the
It adds weight, so what does that do to your sugar percentage? Not quite. It actually makes it lower because your after weight would be more. So that's something you need to consider. So if you have answers like that tomorrow, I'm not going to give you the points. On this one, I think I accepted the word spit just because I knew what you were getting at, but you need to be a little more descriptive this next time. Any questions about that? Okay, so now we're going to do I got a little demonstration for you. So I think what we'll do is, Lindsay, I'm going to have you hop in with this group. So we'll do groups by rows. And then I'll do the demonstration, and then we're going to come back together, and within your groups, I want you to write down some observations that you notice about this reaction, and then we're going to come back together, and we're going to talk about it as a class. Okay? So I'll get started. So once the reaction starts, I'm going to want you guys to kind of gather around. I don't want you very close to it because I'm working with hydrogen peroxide. It's very concentrated, though. This isn't the stuff that you put on your skin. This would probably hurt a lot if you got it on you. So when you're over there, I don't want you to touch it. You'll be able to get close to it, and you'll be able to feel some heat coming off of it. But other than that, I don't want you very close to it. So I'll let you know when you can come back. It'll take me about 10 seconds to get this ready. What's that? Oh. Has anybody seen this before? Some people call it elephant toothpaste. All right, so what color should I make it?
Blue.
All right, I'm hearing 17 different things. So raise your hand if you want blue. We're going with blue. That's good. We did green in the morning, purple last hour, and then blue today. Not today, this hour. Yeah. Oh no, we should have done purple. Well, it's blue. You're getting blue. Okay. All right, let's gather around. All right, I want to stay about this far.
Gather around, children.
Get on this side too. Is that recording?
Go right here then.
It is. Okay. I just wanted to make sure. Okay. Any predictions?
It's gonna bubble.
I hope it does what it did the other times. Yeah. All right. So.
Yay.
All right. So move in. If you want to get about this far away, that's fine. Just don't touch it unless you want bleached fingers. All right. So once you've got some observation, move back to your rows. Discuss with your groups, and then we'll come back together afterwards.
Chemical reactions. That's what we're learning.
It is a chemical reaction.
Nice, Kaylee.
All right, so I've got 2 questions on the board. I want you to discuss those with your groups. Just your rows, yep.
It smells funny. The color change. The original substances. Why did it happen? The thing and the thing and did that. Why did this happen?
That's fair. Yes, we are. Did I give that to you already? Oh, must have.
I suppose.
Oh. Well, now I'm going to definitely hand out 2 anyway.
I had the package you guys, but I still. I'm leaving in 5 minutes.
Okay. We're not going to get to it. We're balancing reactions. Hope knows how to do it. You can come in and get help from him. The point is to make sure that there's the same amount of everything to each side. Yep. All right. So listen up. So group 1, what is your observation? What did you get from that? What did you notice?
Temperature change.
Okay. Let's go. Does anybody know what that is? Yes? Yeah, so delta is that symbol. That just means change in, and then T is temperature. Okay, group 2. What was something you noticed?
Chemicals mix with each other.
Okay. Group 3.
Bubbles.
Bubbles, good. Okay, group 4. Okay, so steam, liquid, and foam.
Well, just put steam.
Okay, steam. So group 5.
Yeah, they went from like the liquid you poured in turned into foam.
Okay, good. So let's go. All right, group 6.
It wasn't like the dark blue of the color, it was like a light blue.
Okay, so the color wasn't exactly what you were expecting. So these are all different signs of a chemical reaction that's occurred. As you guys kind of put together, we are learning about chemical reactions today. So from these, we can talk about the different parts of a reaction. So in any chemical reaction, you'll start with reactants. So what do you think the reactant was today? The powder stuff, what I poured in. So what I poured in, the hydrogen peroxide, that's our reactant. So on the other side of that is the products. That's what the hydrogen peroxide is turned into. So in any chemical reaction, you have reactants, what you start with on the left side when you write it, and products, so you get on the right side. Also, we know that heat is given off in this reaction. In any reaction, it's going to involve heat somehow. In this reaction, it was an exothermic reaction. What do you think exothermic means? Dominic? Good. It means that heat was given off. If it were an endothermic reaction, we would have had to supply some heat to it. So if heat is put into a reaction, it will be noted by that symbol. That's the delta symbol. And it will be written above the arrow. So, a catalyst. Anybody know what a catalyst is? Anybody heard of a catalytic converter? Yeah, what does a catalytic converter do?
Start your car.
Right, it's in your exhaust. Yeah, so it helps with emissions. So what it does is it causes a chemical reaction so that the emissions from your car aren't as bad as what they could be. So what a catalyst does in this reaction was what I mixed up in that little thing of water. That was potassium iodide. That was a catalyst. What it does is it speeds up the reaction and causes it to go faster. A catalyst isn't used up or a part of the reaction in any way. It just causes the chemicals that are involved to react quickly. So in that case, again, it was potassium iodide. If there's a catalyst involved, it'll be written above an arrow like that. So we talked about phase change. I'm glad you guys picked up on that. So in this reaction, we had liquid H2O2 turning into water and oxygen gas. And that's what the bubbles are filled up with. So those were our products. So when you write a chemical reaction, you'll know what phase they're in by these little signs. And those are just solid, liquid, gas, and aqueous. An aqueous solution is just something dissolved in H2O. So the potassium iodide, when I dissolved it in that water, that was an aqueous solution. The difference between that and a liquid is just like something melted. Anybody ever see elemental mercury? Like how it, you know what I'm talking about? That's just melted mercury. That's a liquid. Okay. So if I was going to write out the reaction we just did, I would just write H2O2 on the left. The catalyst is NaI, and then my products on the right side would be H2O and O2 gas. So that's the general form of any reaction that you see. Reactants on the left, products on the right, and if there's a catalyst, you'll see it above the arrow like that. Okay, so when you're balancing equations, backtrack. So in the homework that you'll be given today, you'll be given a skeleton reaction or skeleton equation. Your job will be to balance that, and we'll talk about that here in a second. So, has anyone heard of the law of conservation of matter?
Yep. Yes.
So somebody tell me what it says. Saw your hand first.
It's basically matter can't be created or destroyed.
Good. So he said that matter cannot be created or destroyed. So what that means for a chemical reaction is that we have to start with and end with the same exact amount of each atom, of each element. So, using that knowledge, what is the matter with that reaction? Why? It's not balanced, yes. It has too many oxygens. Good. So, what I can do, so this reaction is always going to produce water and oxygen. I can't say that it produced O3, or I can't say that it was H2O3. That doesn't work, because the reaction is H2O2 turns into H2O and O2. That's just how it is. What I can do is I can change the amount of atoms that are produced or created. And I do that by, So I do that by just multiplying each one. So I can say that two H2O2s react to create two H2O molecules and one O2 molecule. So what I've done is I've added this 2, which then is multiplied into the H and into the O, which means I have 4 hydrogens and 4 oxygens. Same thing here. I have 2 oxygens and 4 hydrogens, and then the O has stayed the same. So by doing that, I have made sure that the same exact amount of atoms are on each side. Does anybody have any questions about that? Okay. All right, so I want you to attempt to do the same exact thing with this reaction. Just make sure that the same amount of each element is on each side. Okay, who thinks they have an answer? Okay, Hope.
You want mine?
Yeah, just say one.
4 aluminum plus 3 O2 results in 2 Al.
Great. So since we have to have them equivalent on each side, you can multiply the aluminum by 2 to get 4. Since you did that, you also have 6 oxygens. To get 6 oxygens over here, you have to multiply by 3. And then to get the same amount of that, aluminum, you have to multiply it by 4. Any questions? Okay, on a scale of 1 to 5, how well are you with me? Okay, all right, so I'm going to hand out this worksheet. So your responsibility within your groups is to come up with the answer for your corresponding number. So group 1 will work on number 1. Group 2 will do number 2, so on. And as you do that, I'm going to write out a practice example on the board that we can walk through together. Okay? Once your group has yours figured out, I want you to come up and write it on the board. Okay? That's Oh, you've got one, don't you? You're probably done with it.
Yeah, I was done with it yesterday.
Really?
Yeah.
Well, that's good. You should be able to help then. Thank you. Get used to the extra copies. I'm not that thorough with them. Yeah. It's not that big a deal, is it? It actually saves me time rather than getting the exact number. Was it a big deal? Yeah. So you're group 3, so you work on number 3. Yes, you can.
Thank you.
I know how to do it. I just don't want to do all the math. So many numbers. What is this? Minus. Hey, Taylor, this is the first one. I just never do this before. Yeah, this is one off.
Yeah, go ahead. This is number 7. Were you going to come up and write it? Oh, okay. All right. Let's go through number 7 together. I've got it written on the board. So my first step is I'm always going to go through and I'm going to count and just see how many of what are there. So I've got 1 magnesium, I've got 2 oxygens, and I've got 3 hydrogens. And I've got 1 chlorine. The other side, I've got 1 magnesium, so that's balanced already. I've got 2 chlorines, which is my first issue because I've only got 1 over here. And I've got 2 hydrogens and 1 oxygen, so that's not balanced either. So this one, I would just start with the chlorine because it's the most obvious issue. So if I need to get 2 chlorines, what do I need to do? Multiply it by 2. Good. So I would put my coefficient here as 2. So now that I've got 2 chlorines, I also have 2 what? Good. So now that's balanced. My next issue is oxygen. So how many oxygens do I have here? Good. How many do I have here? There's actually 3 here.
There's 4 hydrogens.
2, 4. Okay, I meant oxygen. My bad. So how many oxygens are there here? How many are there here? Good. So, put my coefficient is 2 there. Now I have 4 hydrogens, 2 oxygens, and I've got 4 hydrogens and 2 oxygens here. Any questions about that? Yes.
So if you don't put a coefficient by 1, you just leave it blank?
Yep, so that's a good question. So if you don't have to put a coefficient in, you don't have to write in 1. So you don't have to do this. That's not necessary. I wouldn't expect you to do that. If there's nothing there, it just means that there's 1. All right. So work with your groups on your sign number, and then once you get that, come up and write it. For the record, this is going to be homework to do tomorrow. So, yeah, all 10 of them. Yep. I think it's pretty important that you get practice in this. So. You okay?
Yeah.
Okay.
Just confused.
Okay. So what are you confused about?
How these two switch places.
Okay, so that just happens in the reaction. So, on the other side of the reaction, you just get these as products.
So, say if there's 2 silver on this side, I would have to times this by 2. And
Exactly. Yep.
Oh. And then the iodine would be balanced out because there's still 1.
Yep, correct. So you would have to then multiply that by 2. And so now you've got, now at this point you need to go through and check and see how many are there.
So there's 2 AG here, there's 2 AG here. 2NA here now because we times that by 2.
Yep.
Sulfur would stay as 1.
Exactly.
So then it's balanced.
Exactly.
I don't need to put any numbers in this one.
Nope, because they didn't change, so you don't need to write a coefficient.
Would this be a 5 if that's a 3, or would it be a 6?
It'd be a 6 because it's 1 times 2, so there's 2 times 3, so it'd be 6.
Wait, Mr. Klaes, you have to do that.
So that lab is due tomorrow also. So you have homework and the lab right up due tomorrow. All 10 of them, yes.
Yeah.
Yep.
I have all those. Okay. Question.
I don't understand.
Like, I get
Okay,
that I
so
spelled it wrong. But
I'm not counting human error as an error. Like a
17 out of 18.
yeah.
My
So-
group had that too.
Did they not get that counted against them?
No.
I'm pretty sure your group didn't have that because I wouldn't have counted it.
Yeah, look at their paper.
Can I see it? I'll fix it. No, I'll. I'll make it right.
Wait, don't count theirs wrong. I'll take mine as it.
No, I'll give you the point back.
Oh, okay. I was gonna say I don't want them to get it wrong now.
Yeah.